Okay, so this is my Blender talk. I am, obviously, through the text, Ethan Jurman, and I'm going to begin this talk. And it's I'm kind of going to be going over a lot of topics in Blender. Obviously, I can't cover every nitty gritty detail. Um, Doing a project in Blender can be simple or difficult depending on whether you're planning on making a motion picture or a domino physics setup. You know, dominoes, easy. Motion picture, difficult. Um, but hopefully I can give you guys some ideas about what you can do in Blender because I use it a lot and I'm able to accomplish a lot of neat things that, initially I wouldn't have been able to think about. But when you see what Blender can do and when you really think about it, you can accomplish a lot. And why use Blender though? Because there are other programs out there. There's ZBrush, Mudbox, and Inventor, but all of these cost money, and that's not that fun. Unless you like using Sublime, which costs money, but that is fun, apparently. But yeah, so it is free. It is free, which is really nice. Another thing that's really nice about Blender is that it has a huge community. Um, there are people working on development builds all the time. Particularly if you go to like Graphical, right? There's people that upload new beta builds like every 10 hours, and they are doing the craziest, jankiest. Okay, it's not janky, but it's cool. It's cool stuff that they're adding to Blender, and they're really, really doing a lot to mimic some of the really cool features that are in ZBrush and Inventor, etc. So while initially in like 2002, when Blender first started up, you couldn't do very much. And people might say like, "Oh, hey, I used Blender before, and it had a really weird interface, and the renders came out really ugly," and and that was true a while ago, and uh, and you could spend a lot of time and mess with the compositor and everything else about it, and eventually get the render that you were looking for, and get like something really nice. Um, However, with time and a lot of community, they have gotten to a point where this is not the case. They have improved it a lot. So don't panic. It looks nice. It's nice. We've really shift from using an internal renderer, which didn't really provide much power, to cycles, which is not the default one, but it comes with every installed Blender. And it uses the open shading language to create photorealism shapes and textures and the open shading language developed by Sony ImageWorks, Sony Pictures ImageWorks, has been used in a lot of their feature films. Although the renderer isn't Cycles, it's a in-house it's something else. It's an in-house project, but Cycles does use that. It does use the open shading language, which offers really a lot of power. And when you get into it, the writing for OSL isn't that difficult. I like, and I can go into this later in my demo, but really writing a shader is probably like it's some of the simplest code I've ever written. It's just like writing a method, and the nice thing is that once you're done, and they'll tell you if there's, obviously those issues with compilation syntax, etc. But Blender has a really nice syntax of formatting OSL scripts, right? So you're not so when you map everything together, eventually into a final material, it does look really nice, and I'll be getting into it later. But the coolest thing about some of the scripting is using drivers. And what drivers can do is you can take any element of Blender that is scriptable and kind of set it to not only like a baked animation, but you could set it to certain Python scripts. And it's really cool because, and I'll show you the final output. But what you can do is you can have this line of light moving across the monkey's face in a frame by frame sequence, and it doesn't take much at all. It's just a simple code. And I've seen there's some really cool stuff out there with drivers, but I can get into that later. There's also Python because I know a lot of people know Python. I like Python. Boo, right? No. No. Python's great. It's really useful when automating a function in Blender. The really nice thing is that everything that Blender has, if you just like hover over it, you get a hover over text for what the Python code is. And what you can end up doing is, you have Blender has this really neat tool, right, where you can bake sound to a shape or to any sort of shape property. And what I'm doing here basically is I say, okay, I want to bake this sound to a whole bunch of different shapes. And the reason for doing that is because when you bake it, you have to specify your frequency range. Now, if I had to go through all 48 shapes, or it's 44 shapes in here, and bake them, it's number one, it's going to be time consuming because it does take a little bit of time depending on the source file you're using. But also, it's not going to be very fun because I'm going to have to click every shape, keep track of what frequency range I'm using, and then eventually map out each and every one. So what it ends up looking like, and I'm gonna pull up this, right? So, and what it ends up looking like is a little bit like this. Here, let me make sure my audio's up. Blow them speakers, right? Okay. So it's pretty cool. It's a huge time waster if you have nothing better to do. And it does end up with really really nice results. How do I get back to this presentation? Bam. Okay. Cool beans. But yeah. So and that was it. That was the simulation. And the nice thing about Blender is that because it is an animation software, in some factions of it, you can just have the audio in your file, and it will just render that all out to whatever file format you like best. I think that was AVI because it's just like the simplest, and that was using the cycles renderer, which is really nice. But yeah, and if you feel really adventurous, you can write a whole bunch of code. And what you can end up doing, which is what I did here, is you can just write your own scripts for doing any kind of object manipulation. So you have, or mesh manipulation. So what I was doing in this script is I would have a mesh, right, of some sort of object. In this case, hopefully you can tell it was a Charizard mesh. And what I ended up doing is I tried to make a whole bunch of vertices to make like a voxel cloud, right? And just to fill up all the space of the object. And it turned out really nicely. And while the code is kind of nah. I mean, if I did it now, it'd probably be a little bit better. But it's definitely doable, and it ends up being really nice because I never have to leave Blender to do this. Blender has its own text editor in it, and it's not Vim, but it's good. And it's got the syntax highlighting, and the best part, another really good part, is that it has its own shell here, which has says Python 3.3, and it has like the BPY import, which is the import you would need for doing Blender stuff. And it does have tab complete, and it also has method definitions. So if you need to know about what a method does, what the parameters are, all that information ends up being there. And I can show that when I do my demo, which is now going to have a lot of expectations. But yeah, because apparently it's got everything. Yeah, so Blender does, and of course, it has a lot of modeling. People use it for modeling, and it ends up being really good. And it mainly focuses in quads, and people ask me like, oh, why am I using quads in Blender? Like, don't I want triangles? Well, you want triangles, but that's only because the GPU wants triangles. Most of the time you want quads because they offer you a lot of things, mainly animation being one of them, because animating triangles is weird. And also UV mapping, because it becomes a really simple process when you're just mapping a square texture, which most of your textures would be square, hopefully, onto a shape. And while no one's going to get like angry at you because you suddenly are like, oh, I need to put a triangle here and here, it's just whenever you can use a quad, you should. Of course, there are instances, right, where using a quad won't be any good, and people have brought this up to me, right? Where like if you have a shape like this, where I was trying to think of a shape where I could show it, and I ended up having to put a cylinder through the shape, and what you can see is that it's not really forming a plane at all. There are vertices that are not aligned with the two of the vertices are on like one are forward and the other two are back, and it ends up creating this really weird render for the mesh. And there are some points where something like a triangle fan will do much better. Because while this shape is okay, you might end up with really weird topology later on because of what you're trying to accomplish. Yeah, and try to avoid n-gons if any of you are trying to do your own shapes and like, oh, I have this face here and it works because it renders out fine. It's like, no, don't do an n-gon if you can, please. This is annoying. But yeah, in addition to that, listing off all of Blender's cool features, the Blender community loves rigging. They like it a lot. I was actually watching the Suzanne Awards, which is Blender's like sort of suite every year of films that they do, and the animations that they have are fantastic. But a lot of them, of course, the ones that aren't simulations, require an immense amount of rigging, and there are a whole ton of tools to make this rig process a lot easier. People have uploaded into the Blender libraries a lot of easy tools. There's things like the skin modifier, which allows really easy creation of not only meshes but of skeletons for strange objects. And they've also added into the Blender libraries a Rigify tool, which allows you to just add a human skeleton mesh into your project, which is incredibly nice if you don't love animating humans and you just want to map it on there. They make the process very easy and it's very smooth. Also, Blender loves to talk about their sculpting process. And thanks to people like Nicholas Bishop, who develops for the Blender community a lot, we have things like dynamic topology, where if you're trying to sculpt in one area, you don't have to worry about, oh, how many polygons do I have there? And there are things, and he also developed the skin modifier for that purpose to kind of create on the fly. Also to kind of be like ZBrush, because ZBrush is really nice, and ZBrush has those features. So Blender is continually trying to be like ZBrush, but better because it's free. Yeah, we also have things like compositing that I mentioned before, which allows really nice, basically, if you've ever used layers in Photoshop or any program that is image manipulation, it's not hard to do it in Blender, because what you end up having is a bunch of nodes, and those nodes might, add certain panels together of images. So, oh, okay, I want this image on top of this image. I want an overlay, or I want it lighter, or I want it darker. They use the word context that is for Photoshop. So multiply, difference, things like that, and they serve the same purpose. And you can add like on this, right? Something like a blur on the light layer helps really to accentuate like what they were trying to do. Um, but yeah, no, the compositor is really good. You can also composite for individual materials, which is really nice because then you don't. Blender has a lot of cool materials in there already built in, but if you're making your own using the open shading language, or if you just want to do things on your own and make a crazy mixed shader, they allow the node editor so you can start, identifying what the displacement is, right? Like, do I have a lot of like in-grain fields into it, or what the colors are, and how do those interact with maybe the surface normals? And a lot of that can be done easily, although it's always intimidating to work with a node editor. I'll admit that, because I didn't get started into it until a while. I was like, I don't want to mess with this. This is there's also really nice water simulations, physics simulations, fire simulations, smoke simulations. They're really trying to push their simulations because if that's all you want to do, they've made it really incredibly easy. Um, and things like setting up, a field of dominoes and just having them tip over couldn't be easier. They really make it so anyone can jump in if they have. And I've used Blender before on certain simulations just to plan out. Oh, okay, how do I want this? How do I want that? Um, it ends up being really nice for that kind of simulation process. I'm just gonna see this here. Uh, oh, cool. Here, wait a second. Yeah. So also, Blender's also fantastic for game making. And when I say fantastic, I mean there's been one game made from Blender that actually got out there. It's called Yo Frankie, and every Blender presentation must talk about it because we need to remind people that Blender has a game engine. Although I don't know why anyone would use it. It's not that fantastic. However, if you really wanted to use games, if you really wanted to use Blender for games, Unity 3D has a very nice import into Blender, and Blender very nice output to Unity. So if you really wanted to mess with games, you could probably go straight into Unity. But if you felt like you wanted to do game making, you could do it in Blender. However, it is not through. You could do some stuff through Python code. However, there's so many jumps that you have to do that it becomes extraneous, and it's much easier to just go throw it into Unity where they have their whole thing is set up that way. So, right now, I'm going to do a physics demo because people love physics demos, or at least I like physics demos because they're really easy to do. So let me see. I got Blender here. Yeah. Bam. Okay. So, probably like the third most rendered object in history is a default cube. The first being the teapot, and second probably being the monkey head or the bunny. This will actually bring us very far because all a domino is a cube. um, and oh yeah, so I can have the shortcut. I can have the little display that shows what keys I'm pushing. Um, although honestly, if you wanted to get into this, you could talk with me later. There's a lot of tutorials on this kind of stuff. I'm gonna show a couple of websites later that are really good if you wanted to jump into how to do this kind of stuff. But yeah. So one thing that Blender loves is its hotkeys, and you can see that a lot of it, like while there's a lot of mouse movement, you can pretty much do everything you want through hotkeys. And after you make your basic shape and finally move it up. You can make a floor, which obviously needs to be there if you want your pieces to land on something. And yeah, oh, by the way, if you're not using a numpad or a mouse, you're just not going to have a fun time with Blender. It's actually going to be much more of a hassle. And that might just be my machine, because like whenever I use my trackpad, it doesn't take in the input quite fast, and it's just a hassle to deal with. But you know, you just want a mouse. Believe me, you guys will be better off with a mouse. But yeah, so how once I have one cube there, one domino, I could make more and just do that over and over. Of course, I'm not going to be lame like that, and doing it through a modifier, which these are all basically Python scripts in their core, and and as I mentioned earlier, and let me see if I can zoom in. Oh, so right here, right, you see that it has the Python call, the BPY ops object modifier add, and what I can actually do is, if I wanted to, is I could just Control C copy, and what ends up happening is if I did go into a text editor, right? Then all I'd have to do is paste, and that is right there. However, I'm not going to use the text editor because I don't need to do the array thing multiple times. All I need to do is call it once, and as you can see, it put my cube right next to it, and you could set like a relative offset. Oh, nice thing about this is any of these fields can have drivers in them, which is a really cool way of, well, drivers are interesting because there's one thing called keyframes, right? Where I could set this to a keyframe, and then down in my timeline down here, I could set it to another thing. So maybe 100. And as long as I set that key, which I have done, and on the timeline there's 2 yellow bars, it will animate between those 2 keyframes. I can just run that animation. Of course, it's a interpolated value. So it starts off slow and then ends off starts off slow, medium, it gets kind of fast, and then it ends slow. And you could change that, but I'm not even going to bother with it because I don't really need keyframes here. And so get rid of that crazy thing. And because this is a simulation, not an animation. Well, I guess they're the same thing ish. Kind of. You can do things. But yeah. So the count. So maybe I want like 100 dominoes, and I just realized that I need to make this plane longer. So I'm gonna do that. There you go. Whoa. Okay. Cool. 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 And I said this would be easy. So this is the part that's easy. So over here they've added in the newest version a list of everything that you would want to do, and before they had it all spread out and it was crazy. But it's really nice because people were complaining about hotkeys and were like, "Oh, how do I add things?" It's like you push Shift A. That's how you do it. But you could also do it here if you really needed to. But what we're looking at is the physics panel because physics are cool. And oh, great. So, and I could add a physics to this, and adding an active physics, or rigid body, excuse me, adding an active rigid body allows this to have properties of the world. And if I push Shift A, which animates it, or no, Alt A, those hotkeys. So if I push Alt A, they'll all fall because they don't know what to do. Because right now this plane is nothing. I could go into this plane and make it a passive. And when I add a passive rigid body, that means that it's part of the real world, but it's not affected by other objects. Basically, it's one of them unmovable objects. You know, the ones you find all the time, around. So you do that, and they're not doing anything. Well, I mean, that's kind of expected, because they're just standing there. They're supposed to stand there. Good. They didn't move and freak out. However, these are all connected to each other, which becomes annoying because, obviously you'd want them to act separately if you want them to all fall right. What you can do is just, if you apply the array modifier, the one giving us all the dominoes, they're all still connected, but when you go into edit mode, they're all their own piece, which is cool because then hotkey P, we can separate them, and the separation can be done by loose parts. And when you do that, all these are now their own shape, and they're really nice because now they're all part of the same. They're not all the same object. Now I'm gonna run this, and it's gonna freak out. So I'm not screwing up here in my demo. This is supposed to freak out because what's gonna happen is they're all, yeah. That's if anyone has worked. Okay, just disclaimer. If anyone's worked with dominoes, that's not how it's supposed to work. Um, so what's happening is every object has an origin point, and that's kind of where it's doing its math. And you can tell by that little orange dot, this orange dot, right? And all these pieces, since they were made from the same shape, still have that same orange spot. And that's not good, because we don't want to do our calculations from all the way over here. So what we could do is we can just, what I do is a circle select, which allows me to access any object that I hover over, like the lamp that's there. I don't need no lamp. Get out of there. But yeah, I can select all the objects, and now they're all highlighted because I circle selected. And thankfully, this was really hard to do earlier, but Blender's gotten better, and they realize that people love doing this. And in the object properties, we can just say, okay, I want my origin to geometry, which basically says do a fancy math calculation and figure out where my origin should be. And it does that, and now we see all the orange dots where they're supposed to be. And then if we run it, they're still not acting quite right. And that's because these objects don't have quite the right physics properties. So its initial property isn't really defined, and we want them to be a box, because what we can set here is a collision shape. For like the plane, I'm just going to set it to a box because it is a flat box in essence. And for these shapes, which I'm now going to tilt like this. There we go. Needed to select them all again. Okay, good. They're all selected. I can change the shape to a box, and hopefully they'll work now. But I won't expect anything to happen, so I'm gonna do a little bit of cheating. Move this piece right there. So this piece is gonna hit that piece, and if Newton's laws are right, we should get something that is kind of cool. Oh no. Well, oops. Yeah, oops is right. Okay, so oh, I know why. So when I initially did this, I made these boxes a lot smaller. What's happening is that their mass is huge. So what I'm going to do, yeah, yes. So what I'm going to do is there's a physics property over here, and I should be able to change the mass. And what I can do, hopefully if this works, is just change the mass on this one. I'm going to make it a lot. Oh, and the cool thing is with Blender, if you don't like working in random units, you can change these to metric or imperial. And metric being the metric system, and imperial being, feet, what America uses. Ugh. God, why? So you could set this to whatever. I'm going to set it to 10 ton, because why not? Also in your animation, so I was looking up because I was running into similar issues before, and what ends up happening is there's a place where rigid body and physics, the world kind of has all these settings, which kind of tell you how much cache you're loading into the um, the properties, because what ends up happening is it kind of it fudges the values, and what will end up happening is, yeah, steps per section, and basically it says, okay, how many calculations should I do, and yeah, it says number of simulation steps taken per second, and higher values are more accurate but slower, and that's why oh, not that high, yeah, good, usually good value is like 115. And that's why like pieces were falling over here, is because they didn't know, like it wasn't calculating 100 pieces, it was calculating 60 pieces and kind of just interpolating values. So hopefully this works. Yes, and they're all falling, and those are still falling. That's because they're bad dominoes. And they fall, and oh right, my animation isn't that long. Good reason to not generate 100 dominoes. So yeah, if I just select these, those are those are gone now. Whenever your simulation doesn't go right, try doing less of it. But yeah. Oh, hey, you were supposed to be tilted and up in the air. Yeah. Okay, so yeah, hits them. They all fall over. 'Cause dominoes. It's really cool. It's like, oh man, dominoes work really cool, and so the default render time is 250 frames. And don't ask me why. Some guy thought that would be a cool number to use there. Yeah, whenever there's like some random number, just don't try to find a reason for it. It's almost a power two. Um, but yeah, and that's really cool. But what was if I don't want to just do this all day for animation? Because like that's cool, but it's not. Nobody does that all day. Okay, wait. I may have built a large domino set at one point in time. But now rigid bodies are cooler, and I don't like showing off that simulation. Um, but yeah, so other things you can do with rigid bodies. I have a little file set up here, and what ends up happening, so in this, right, what we can do is, this is just a basic shape, I believe. Yeah, no, it's just a simple shape, uh, and it's actually just a tube, like a half pipe, a very simple half pipe, and there's this ball over here, and this is a passive and this is an active, and when we run it, as anyone would expect it does, it kind of just falls down and loops. And the cool thing with this is, and why I bring it up, is because your physics animations don't have to be at one camera angle, or at least, I mean, you don't have to. And what you can end up doing is there's a camera here, right, where it's basically doing a tracking field on the ball. And this is really cool because all you have to do is set the a track to, right? And I have it tracked to an icosphere, which is this. And when I push 0 on the numpad, I'm just following it. It's so legit. And yeah. So initially, it's a funny story. Initially, I had this camera, like all the way here. I was like, "Oh, this is gonna be so cool." And when I did it, it was like so obnoxious. I was like, So don't put your camera in a weird spot. But ignoring the camera, because the camera's only half cool. The cool part about this is that this, you're like, okay, Ethan, you brought up this tube thing, but why is it a circle now? It's because it's actually following this curve. So Blender has these things called curves, which, unlike meshes, allow for very good curvature values. And they have a circle, which is the one I'm using here. And if I was to disable it, the curve modifier, you would see it's just a straight pole. But when I apply it, this one, yes. So it, and this is really cool, but you're like, and this is how curves are usually set up. They have a bunch of hooks that you can modify. And what I can do with this now is I can like set it like that. Okay. Well, I wasn't supposed to do that. So yeah, like I can change this, and it's really good for like, okay, I have this one design that's a tube, but I want to do something more with it, and this is a lot easier than going into the tube and start modifying every single value. Trying to extrude it in awkward angles. But what I also can do is deleting all the vertices here and letting it fall to its doom, um, is I can have any kind of shape I want, in here. So I can make a wiggly waggly path, and we don't want you here. But yeah, no. Yeah. You gotta be careful about what you do after that, though, because then, like, as you could see, if I try to move this shape, it's still trying to follow the curve. It's just like, yeah, you're gonna want to mess with the curve if you want to do things. So, yeah, if it gets there, it's fine. It's good. Don't worry about it. um, but instead of modifying one shape, we could do things like modifying arrays. So, if we have a set of cubes, right, and we have an array, let's set this a little bit distance apart, and 180 values. We can then create a curve. We could do a path curve. And what this curve allows us to do is kind of shape where these cubes will end up going. And again, another modifier. All we have to do is set, okay, hey, this is going to deform in the shape of a curve. And once we say, okay, which curve is it, it does that. It's really cool because then, as you could see, it kind of followed the curve all the way to a point. And that point is right here, and then it just continued on going in a linear equation fashion. And I can then change, how these are set up by changing how many are in the array. And that becomes really cool when you start doing things like dominoes, because then we can have a path of squiggly dominoes, and that can take no time at all because we have all these cubes. We have this NURBS path that they follow. And of course, I already applied the array modifier, so I can't. If I modified this, it wouldn't do anything. It's eh. But however, it does make for a really cool animation that I'll show off right now. And I was gonna show this. We have a ball here, and this is one of the instances where you would actually change the shape to a sphere, right? And I'll explain these right now. So this the ball obviously is a sphere because you want it to roll correctly, and that was the same case when you were doing when I was doing the ramp. And this shape, which is, and I'll bring it to a different layer. This shape, which is kind of a weird tube thing. Doesn't really follow any of the other shapes. So what I set that to is just a mesh, and that's for more complex shape, like the Suzanne head, which over here shows the monkey. Which, by the way, fun fact: the monkey head comes from a right before the development team was going to give away Blender to the open source community. As sort of a last project update, they added a monkey head called Suzanne, which is a reference to Jay and Silent Bob, which get an orangutan, I believe, during the film. And so that's why it's there, and it's their thing, Blender's thing. So if you ever see a monkey head, you can be like, "Oh, cool, Blender," I guess. I don't know. If it's me, I'm gonna be like, "Oh man, Blender, oh cool." But yeah, I don't know. So yeah, and you end up getting these really cool paths, and the ball does roll, and the dominoes do fall. And you see, when you set up your demos beforehand, they all fall correctly. Oh, why did that? Okay, well, it's okay. You got Yeah, there's like 250 dominoes. So, if the last one doesn't fall correctly, you just hide it. Um uh but yeah, so no, it's really cool and you don't have to deal with setting each one of them up, and you can obviously do a lot more with it. Depending on whether you're animating it or you're doing other shapes, right? And maybe you want to set up a scenario where this giant ball hits a thing. And as we've seen before, we can set up weights, and they do follow those properties. And what you can also do is there's a lot of things you can do as far as what properties go into there. I'll actually, if I haven't saved over this file, I can open it back up. Yay! Okay, cause no, I want to show this off. So what we can do here is we can increase the friction of this rolling ball, right? And it does play a good part because then it's sticking to it. And if this had friction up all the way like it was supposed to, yeah, it starts stopping a lot sooner. Yeah. Of course, physics, so it is going to roll a little bit. And it is a ball. If I made it a cube, it wouldn't do that. Um Box collision. Oh no, wait. Oh, I made the tube a box. That was bad. Be a box. Sphere. Yeah, so it shows the collision boundary, and it's like, what do I do? I'm a box. So, yeah. It's not. You want that. You pick whichever shape makes sense. Capsule, cone, convex hull, a mesh-like surface encompassing all vertices. Best results with fewer vertices. Eh, just use a sphere. It's a sphere. And it'll work. Um, like magic. But yeah, so that's getting people interested in the physics stuff, because the physics stuff by far is the most cool when it comes to certain certain aspects of real life. And I would show. I had a water one, which I'm gonna bring it up because I think it's really cool that Blender has gotten this far to do really cool water sims. But it's already pre-rendered, and if I did a water simulation here, it would take way too long. It still takes a long time to render water. Don't kid yourself. Um, but it is significantly better than it was before, and the results are fascinating. If I can get, uh, no, it doesn't. It didn't save the render. Of course, I didn't save the render. But yeah, no, you can get really cool results. And actually, no, wait, I can render this. What am I doing? Okay, not that. That's wrong. So yeah, we have. I was making similar to the slide I showed earlier. I was making a ball hit water or fruit, moreover, and what that ends up looking like. And awesome part about cycles is the inclusion of a render live kind of deal. Um, yeah, so I was making like a fruit hit water thing, and it ends up being pretty legit. I liked how my fruit came out. Yeah. Bump maps, guys. Yeah, and I can actually talk about that right now. Good segue. Right, right, right. Good. Talking to yourself. Bad segue. So yes, yeah, if I can finally get to that layer. Yeah, this shape, and what a lot of people do when making simple shapes and stuff. Well, I'm gonna do it on time. Whoa, whoa, man, that blew fast. Um, do I want to talk about bump maps? No, I'm gonna really quickly talk about shaders. Because shaders kind of go into bump maps if you do cool stuff. So there's a Suzanne head, looking all Suzanne-y. And I have a cube and a sphere and a plane. What is that? Oh, that might be that used to be my light. Oh, light. Okay, so right here I have three objects, And what I wanted to talk to you guys about really quickly, while I still have time, is shaders. And they're really simple. Basically, what they end up looking like is you have the shader, which is basically like a definition of what you're building. My method name, and all these end up being your inputs. So I have a point value PO, and P is a reference to the Open Shader language point, which is the point that it's rendering at. I have a float value amplitude, and out right here I have an output color. And what ends up happening is that the output color down here in the actual method, what it's compiling and working the math on, is it's going to set it 1 over the absolute value of the 0.0, which is the x value, and the sine point value 1 times the amplitude. So what that ends up looking like is a little bit like this. And it's pretty cool. And what we can do, I'm going to delete the driver real quick, is we can modify this value and have it go across all the objects. And this is a really good example about how drivers can do things that, if you really want nitty-gritty details, you could do this instead of some weird, Boolean modifier on the object. Like, if I needed a stripe into this object, this would probably be one of the better ways if you were making, like, a dice or something else. Instead of trying to map out all the points, you just write a shader, and it's going to do all the math for you. You can also set, so this is the, right over here. This is where all the node editor is. It's really easy to just, they have all the inputs. So if you wanted to mess with geometry of the object, you can get that and input the position, the normals, the tangents, etc. And the outputs, so the material, the world output, and they have a whole ton of shaders. And these shaders are really cool if you just quickly need something. Like, for instance, the water back there was just a glass shader, and they have index of refraction, and they do the math there. So you can set, 1.333, which is the index of refraction for water. I think refraction or reflection. It's one of the R's. Yes. But here I'm just adding a script of my own. It's called Crazy Shader, creating crazy shading. And I can the point value is default to P, which is where I want the rendering to occur, and the amplitude is just 0.5. And I can just change that over the course of here. But sometimes I want, wouldn't it be cool if I could get that going over time, right? As I said before, I said I'd show you guys that, so I'm going to do that. And what we can do is, on any value, I can just right-click and add a driver. And over here, I have my graph editor up, and I can just go over to the driver panel and set it. Okay, so what's the script I want? And over here, you can actually write your own Python scripts in like a new file over here with your text editor, or you could just say something like I always like frame, right? Because that's a Blender like kind of default thing, and it'll map it to the frame. And what that ends up looking like is I can just animate. Oh, right, I gotta accept it. Bam. And make sure it's going to the color value. Womp womp. Okay, so this was... I feel bad, because I promise you guys this would work. So, oh, I think I know what's happening. Wait a second. Don't kid me now. Add passive. And you used to work so well. Okay. I'm gonna cheat my way out of this. There we go. Yeah, I don't know why that wasn't... Yeah, I've been having trouble. Okay, so I'll admit something right now. I've been using the OpenShader language for about 5 days. So if I can't solve a troubleshooting error in my demo, I'm gonna reload to a file. But yeah, it ends up working, and I think the issue before, now that I think about it, is the way that Cycles imports its shading language, and I should have just refreshed the language. Um, yeah, because there's a script node update here. So that works really well, and you can do so much with shaders. And if I wanted to, I could instead set this to something like displacement, right? And I'm gonna have this really quickly just be a light, and um, oh, it doesn't know how to render the light. Yeah. Um, and what you can end up getting if it shows it. Yeah. I don't know if it's going to show it very well. But what you can end up doing is having, and this is not the best example, but you can end up doing having displacement bumps on your shapes. So you can choose to, have a texture map that becomes a bump map, and it works really, really well when trying to make things like fruit, and where the texture map is very necessary and you don't want to model all those intricate details yourself. And yeah, so that was just. Oh, I really wish I had more time, but I absolutely do not. So I'm going to go really quickly back to my presentation. But yeah, that was really quickly just me fooling around with Blender, kind of showing you guys what you can do. That it's not all just fooling around, because you can do physics simulations and shaders and Python to do really cool stuff. There are a couple of websites that are very good. The first two are excellent tutorial sites, Blender Cookie and Blender Guru. Although Blender Cookie recently has gotten very like, oh, you should subscribe and pay $10, and it's like, ugh, I don't. I'll do that. I do that, but it's just you have to really be at a certain point before you start investing money into Blender, I feel. Blender Guru is excellent. Blender Artists is a forum website that has pretty much every question you have beginning with Blender, like how do I undo this crazy operation that I just did? They'll have the solution to that. Blender.org has all the information where you can download Blender and the Blender Python APIs, the documentation for that. They're about as good as the Python documentation, so take that as you will. The open shading has information about the open shader language. It has examples and some really cool tutorials to just get you started on rendering Suzanne head with crazy properties. That is it for my presentation. I ended up having the demo earlier. But if you guys have any questions, I can answer them. If not, I can answer them later if they're really weird questions. I'll try to answer anything I can now. Does anyone have any crazy questions? Oh man, people. You. So, yes, that's why it wasn't rotating quite right. Although I've tried to have other things where it did rotate correctly. The ball. So yeah, the reason why the ball wasn't rolling was because in the ramp demo, the tube, right, is because it didn't quite have the friction properties that I wanted it to. Yeah. I should probably fix that next time I show people that demo, because I even noticed that. I'm like, why isn't the ball rotating? But no, you're right. It's because of the friction. It's weird. Like even if you set friction to 0, it still has some friction. It's just not. It's not like it's going to fly off the world. So it does have some friction. It's interesting. I don't know all the math behind it, but they get it to work good. Any other questions? Over the back.
Being free, what would you say is the top advantage of using Blender
So the the best advantage for using Blender, other than it being free, would probably be just the fact that getting into well, okay, so being free is a huge part because getting into 3D modeling, like when I first did it in like high school, I had no idea like what I was doing, and it was good that I didn't spend like $300 on software to get my feet wet. Um, the really nice thing about Blender is that it has such a good community of people that are just starting off in the 3D world that you're not intimidated when you because like I've gone to ZBrush before and looked at their forms and they are doing crazy things and they definitely need to use ZBrush because they are at a level where they're trying to make money off of it and I feel Blender is much more of a hobbyist 3D modelers thing which at this day and age kind of comes with an advantage because we have a very large group of people working to get features that are very cool in the Blender. Right now, there's 2 part-time people and 2 full-time people working on Blender. So what they and the community have all accomplished as far as getting Blender into a really nice working professional level is, I think, amazing. So just honestly, just the community and the resources online are just fantastic. Any other questions? Yes. So open shader, language, whatever. When you were saying there's a site with stuff to do, is that all for Blender? Or? So the open shading language, as I mentioned before, is developed by Sony ImageWorks, Sony Pictures ImageWorks, and they the open shading language is used in about a dozen different 3D modeling rendering tools. So while while it doesn't have like examples for Blender specifically, it doesn't matter because it's going to support it the same way that any of those 3D programs would, except for the one variable time, which I don't think has been implemented in Blender yet, but it you can just add a driver and it should work if you want to set it to frames, which honestly kind of offers you some more possibilities when you start using drivers to do animations and things. Um, but yeah, no. That site, Open Shading, is really good for just everything you'd want to know. Any other questions? Oh my god, I taught you guys all so much that you don't have any questions at all. But while you guys should be thanking me, because I filled your heads with knowledge, I will thank you because you're all awesome, and hopefully you're not so scared of Blender or of me when I talk about Blender, because now you know so much, and when I blabber on about these kind of things, you'll be like, oh yeah, I know what you're talking about. You're that creepy guy that gave that presentation. I'm like, yeah. Okay. Thanks for being here. If you have any more questions, ask me later. And you're all beautiful.